Hello friend, welcome to the Java puzzle. Today in this part we are going to discuss about the thread priority and the yield method. So in the previous part we have seen how the order of thread execution happens and the join method to join the currently running thread at the end of other threads. Okay, so we have also learned that there is no guarantee in the order of threads execution. In this part, we are going to discuss about the thread priority and how we expect to gracefully threads can take their turn using the yield method. But before understanding the yield method, it is really important to look at the thread priorities. So in the Java, thread priority are just the number from 1 to 10. 1 being the lowest priority, as you can see in the thread class, the 1 being the lowest priority and 10 would be the highest priority. The scheduler in most JVM is priority based preemptive scheduling with some sort of time scaling. So what does that mean? Preemptive essentially means turn taking. The thread takes CPU turn after some time elapse, and which thread to take its turn next depend on the priority of thread. But the thread scheduling algorithm vary from JVM to JVM, and even JVM specification doesn't specify which scheduling algorithm to use. It all depends on how the thread scheduler is implemented in the particular JVM. We cannot even guarantee whether all the JVM use thread priority in the first place. They may also use round robin with the time slice. There is no such rule enforced anywhere in the JVM specification. But in most of the JVMs, the thread scheduler does use the priority in one important way. That is when a thread enters the runnable queue and it has a higher priority than any of thread in the queue or higher priority than the currently running thread, then the lowest priority running thread will be pushed back to the runnable queue and the highest priority running thread will be chosen to run. So in most cases, the running thread will be of equal or greater priority than the highest priority thread in the queue. Once again, there is no guarantee and we should not rely on the thread priority to state the correctness of our program. One more important thing which you have to note that never ever rely on the thread priority to guarantee the correctness of your multi-threaded application. What is also not guaranteed is which thread will get picked up from the queue when all the threads have the same priority. You will see that the default priority of thread is 5 if none is specified and the thread class has the, if you will see here, this minimum priority would be the 1, normal priority would be the 5 and maximum priority would be the 10. So if we will not pass any priority, that means that would be the norm priority. Now what does the method yield have to do with the thread priority? Well, yield method is supposed to push the currently thread back to the runnable queue to allow other thread of same priority to get their turn. So the intention of using yield is to request gracefully turn taking among equal priority threads. But you know what, yield method is just a request. There is no guarantee that this request is honored by JVM. I know you get bored me to saying no guarantee, no guarantee, no guarantee, but that is just the reality with the Java multi-threading. It all depends on how the thread scheduler is implemented in particular JVM. So just sink this fact into your brain that there is no guarantee. Yield method will pause the current thread and pick up another thread of the same priority from the runnable queue. Again, no guarantee, right? Just remember that thing. So all in all, yield method won't ever cause the current thread to go to the waiting, sleeping or blocking state. At most, yield method will cause a thread to get pushed back to the runnable queue, but again it might or might not have an effect at all. Also, the state of the thread won't ever have an effect. That means if you can call yield method on the current thread, the state of thread will remain runnable. Okay, enough of no guarantee business. Now that you understand yield method, let us revisit the other method like slip and join method from our previous videos. So I will give the link of this video in the description section if you want to see how the slip method, how to join method is working, so you can check my previous videos. So generally I'm just giving you a brief intro of this method. So a slip method causes the current thread to pause for at least the specified duration and put the thread state to the time waiting state. And yield method not guaranteed too much of the anything. Yield method merely a request and not guaranteed to the owner by the JVM. But the expectation is to cause the currently running thread to leave the CPU and sit in the runnable queue, so that the thread of same priority can take a turn and get executed by the CPU. While a call to join method is guarantee to cause the current thread to pause until the thread that is joined with method is completed, right? Apart from these, we have some other methods like wait and notify that are called on the specific object rather than a thread class instance, right? So we will talk these methods later in our upcoming part in detail when we will discuss about the synchronization and logging. That time we will see this wait method and notify method. Right here, if you will see the program yield demo, so in this program it's illustrate yield method, right, and run it multiple time. Let me run this program first. When I will run this program multiple time and see the behavior. If you have a presence, you can run it on a multiple JVM as well as, right? So here you will see main is finished, then T1 state after the yield runnable, then T1 state after the runnable, then output is 5 6 7 8 9, means no guarantee. If I will run it again, and you will see that after the main is finished, then this one. So in this program you will see we created a runnable with the name let me minimize it, and if you will see that in this program we created a runnable with the name R1 with a lambda that print 1 to 20 in the console output. Then we created and started 3 thread T1, T2 and T3 with the runnable, that particular R1 runnable, right? So here two things we can observe from the output. Let me run again, and you will observe from this output. Here you will see when T1 is yield, T1 state yield, then ideally another thread either T2 or T3 is expected to execute it, but T1 is continuing, right? Here you will see when the T1 is yield, then T1 is running after that. Here also you will see when the T3 is yield, then the next thing is T3 is running and it will run till the 9. Then T2 is yield, then T2 is running till the 9. Then again it will run, T3 is yielding again, then it will run till the 14. So here you will see the 5 it is running after the yield, right? And when it's completed, then only the when the last one is run 20 we run in the program. You will see that we running till the 20. So when it's reached to the 20, then it's running one time because it's completed their task, so it's running there. But after that you will see that T1 is yield, then it run till the 5, and then T2 is yield, then T2 is running till the 5, right, and so on. It's a summary time. So each thread in the Java has a priority. Thread priority are just the number from 1 to 10, 1 being the lowest and 10 is the highest. The default is 5 if none is specified. Then the call to the yield method on the current thread is expected to put the currently running thread to runnable queue and pick up another thread with the same priority and start executing it. However, this behavior is a JVM specific. Unlike slip method, join method, wait method, and the method yield won't ever cause the current thread to go into block waiting state, right? The thread will always go to the runnable after yield method. In fact, there is no change in the state of the thread. So that's it for this video. I think you will understand about the yield method. If you do have any question over it, so just comment below. So thank you for your time.